Hello. Hello.
Am I audible, sir?
Hi, ma'am. Yes, you're audible now. I'm just checking with my student. She's going
Yes,
to
sir.
join. Yeah,
Yes.
let me check. Hello. Hi, good evening, Rudy. Can you hear me?
Yes.
Okay. I think you're not audible clearly. Can you hear me?
Yes, sir.
Okay. So we have Suhani ma'am with us. Okay. She will be your mentor for mathematics. So Suhani ma'am, you can just introduce yourself and then we can just start.
Yes, as sir has already told my name is Suhani Rudhi, and I have some experience in teaching science and mathematics, which is around 8 to 9 years, and I'll be taking your classes if this goes well. So we have our demo class today, which is on this topic, which is simple equations. So shall we begin, sir?
Yes, ma'am, we can start.
Okay, okay. I'll be now sharing my screen. Ruby, if you can please confirm when it is visible to you. So is it visible to
Yes,
you?
ma'am. Yes, ma'am.
Okay. So do you have any idea about what the topic is about? It's okay even
Calculation.
calculation. So maths anyway is going to be some kind of calculation. Yes, we have similarly in simple equations. So there's a small example or an activity given for us to understand maybe how we can use simple equations. So there's this small game before we start our chapter, we can use it. So here they're saying that if I want you to just think of a number which is between 1 to 50 and you do not tell me what it is. So can you just think of a number which is between 1 to 50?
Yes, ma'am.
Okay. Now there's another step is let's say that they have now you can what you can do is you can multiply that number by 2 and then can you add it and add 3 to it.
Yes, ma'am.
Okay, you are done. Now, when this activity was shared, and maybe we have taken some number, and you keep your answer somewhere in your mind, that whatever is the answer that is coming. Okay, we will see if this topic which we are about to study is it helping us to find out that number or not, whatever was that result. So, what you need to do is you know the number, right? And you know, just a minute, I think here again I will have, yes. So you know the number and you know that what is the result. So you keep it handy with you. and then we'll see how simple equations is going to help us solve that. Okay, so just give me one more minute, Rudy. I think I will have to copy the slides because it is, just give me 1 minute.
Yes, ma'am.
Okay. I'm using the same slide. It's just it wasn't giving me access to write, so I'm just copied everything on this one, if that isn't a problem. So I'll explain to you. I hope my screen is visible to you back.
Yes, ma'am.
Okay, so here I'll explain to you what maybe there was in a class they had given to many students the question, and there was one which is Sarah. So Sarah was there and she also thought of a number. And what we'll do is we'll try yours and then we will see if the result is coming, what your result is. So can you tell me at least your answer? No, don't tell me the number, but can you tell me the answer?
23.
What is it? Can you be louder?
23.
23. Okay, so 23 is your result. Okay, we'll see. So now I don't know your number. Okay, so it could be anything between 1 to 50. So what I'm doing is I am assuming that Rudhi's number is something I'm naming as X. Okay, I'm naming it as X. Now I told you to multiply that number by 2. So if your number is X, can I just write it as 2 into X, or can I write it as 2X? Can I do that? Or if it is
Yes.
confusing to you, what I can also do, let's assume it A, because into and X sometimes confuses children. So let's take A. So what can I do? Can I do 2 into A? Is that right if I'm doing?
Yes, ma'am.
Okay. Also, as I told you to add 3 to it, so I'm adding 3 to it. Okay. And like you told me the result, I'm also writing the result equal to 23. So is this somewhere relating to what you must have done, right?
Yes, ma'am.
I'll put a bracket also here so that we are less confused about it. So here now what we have finally, we have 2a plus 3 is equals to 23. Now, if I can also, I think I can do this. Can I move the 3 to the right hand side and can I write it as 23 minus 3?
Yes.
What will be the result of 23 minus 3?
20.
20. So here it was 20. And then can I say that your number was 10?
Yes.
Yes. So, did you see how math has actually helped us guessing what is going on in your mind? You disagree?
Yes, ma'am.
Okay, great. Fine. We will also take up another example, like I was mentioning, that in a class, maybe there was Sarah also, and there was another task given, a similar one, like given to you, to Sarah, and we have checked with the her number also that what could be her number. So Sarah also thought a number like you did. We multiplied it by 4. I mean, after not knowing that number, assuming it as X, and then adding 5 to it. The result was coming out as 25. Like yours was 23, hers is 25. So again, what we did, if you want, I can go ahead with X, or else if you want, I can go ahead with A. Are you comfortable with X, or you want me to
Yes,
take
ma'am.
it
I'm
as A?
comfortable with it. X.
You comfortable with X? That's great. So if you're comfortable with X, then the number as it is mentioned is X over here. And she was told to multiply it by 4. So 4x, 4 into X is 4x. Then we added 5 to it, so plus of 5, and that was equals to 25. So now 4x is equals to
So, ma'am,
25
the number
minus.
is 5.
Yes, I think so. So you're right, absolutely. So x is going to be then 20 upon 4, which is 5. So Ruti, that's great. You are very quick in mental mathematics, so that you did it. I think you did not use the pen here, which is great. Okay, so let's go ahead now. We also have another question. Would you like to give it a quick try?
Yes, ma'am.
Yes, please. I'll give you maybe 30 seconds to 1 minute time. If if you're able to do it sooner, that'll be great. So here it is Dylan who is thinking of a number, multiplying it by 3 and
And the answer is
subtracting.
4.
The answer is 4. Okay, let's check. I think you're right, but let's check. So let's assume again the number is x. So we are multiplying x to 3. We are subtracting it by 5 and we are saying the result is 7. So 3x is going to be equal to 7 plus 5, which is 12. So x is going to be equal to 12 by 3, which is 4. I think you were told the answer is 4 only. So that was very quick of you. Great. Now, we have some more questions. I would like to start in opposite order because I think the first one is very similar to what you have just tried. So instead, let's go in opposite order. So we will try with the fifth question. The temperature increases by 18 degree and the temperature is now 15. So, how can you represent this statement as an equation? Have you understood, Ruthi, that what is meant by equation here?
Yes, ma'am.
Can you explain it to me?
The sum that is being given when we take out all the numbers and the calculation we are doing that is the equation.
Okay. Have you been using this word equation earlier also, or else this you've heard for the first time?
Yes, ma'am, sometimes.
Sometimes you've heard. Okay. So you are right about this. That when you're expressing something which is okay. Now that you thought of a number and I called it as x or a, can I categorize it as something? I mean, you could have thought one number, your result was something different. If I had a class of 20 children, then someone else could have thought a different number and their result could be different. So, can I categorize or else can I say X is something? Can X change?
Variable.
Yes, very good. So here X is a variable, and I was looking for that. Thank you. And if you are adding, let's say what you did, I think was you added 3 to it. So what was this? Is this also a variable?
No, ma'am.
That is
An integer.
integer. Or can we say it remains constant? So it is a constant?
Yes. Yes, ma'am.
Yes, okay. So we use the term variables for the unknowns which can keep changing as we put in the value of x, and something which cannot change its value, we are going to term it as constant. Okay, so yes, can you now help me doing question number 5?
Yes, ma'am. And minus 3 plus 18.
You're saying the answer is minus 3
Plus 18.
plus 18. That is the answer.
Ma'am, it says to represent the statement as an equation.
Okay, so there is, I mean, though there's no variable here, you're saying, right? Is that what you're saying?
Uh,
I mean, if I'm writing minus 3 and plus 18, I can, I think you must be knowing to solve this. This is going to give you the result as 15 only, right? You want me to tell or you want to give it a try for another
x plus
5?
18.
X plus 18 is equals to what?
The answer is
Okay, why did you take it as X?
because it can increase by any amount.
Yes, so it could be some particular temperature which we don't know. So I don't know your city, but then let's say there could be some temperature right now in your city or in your area. So it is increased by 18 degrees. I don't know what is the temperature of your city or your area. So I cannot just calculate it. So that's why we can't just put anything and we can calculate it. So your answer was, I think it's coming close to what is the right answer. But then at the same time, I don't know sitting here that what's your temperature. So I'm again assuming that temperature is X. It is increased by 18 degrees, right? So if I increases, then I'm going to put this addition sign, and plus of 18 is going to give you the results as 15. Now they are asking you to represent it as an equation only, but can you tell me what is the value of x?
-3.
Okay, so that is quite a cold place. Yes, if it that will be -3 degrees. Okay, whatever unit you want to take there. So -3 degrees. Okay, so that was about the fifth question. Okay, let's see if you can also do the fourth one. Yes, please.
X into 1.
Okay, x into 1 is
X
equals to
plus
20.
X plus 1.
X plus 1 is
25.
yes. So when an equation is asked, Ruby, so we have to write it both as the left hand side and the right hand side. So we can't just say what is on the left hand side of the equal to sign. We have to tell both sides. So you're right here. Can you explain to me how you did it?
So a student will be only one student, and the class has 25 students now, but there can be any number of students in the class. So that will
Correct.
become X. And they've already told the answer is 25. So X plus 1 equals 25.
Very good. So I think what can you now tell the strength of the class?
25.
25 is the strength of the class. Okay, right now. And what was it previously?
24.
Very good. So 20x, can I say x is equals to 24?
Yes.
Okay, let's try out the third one now.
2x equals to 24.
Okay, let's understand. A farmer has a number of cows and he plans to double that number next year when he will have 24. So you are saying that we should write it as 2x is equals to 24. So how many cows did he have earlier? I mean in the present year maybe?
12.
12. So that's correct. I think we're not missing any plans to double that number next year. Yes, that's how it goes. So 24 divided by 2 is equal to 12. Okay, I think now second and first will be super easy questions for you, but let's quickly finish those also. Yes, come on, second one if you would like to quickly tell.
X minus 5 equals to 10, and X is 15.
Okay, so Joanne thinks of a number and subtracts, and then subtracts 5, uh, and the answer is equals to 10. So what did you tell as the answer?
Uh,
Final, what is the value of x?
15.
Yes, so that will be 15. Okay, the last, I think I'm in the first one now.
X plus 3 equals to 15, and X is 12.
X plus 3. So Brendan thinks of a number, adds 3 to it, and the answer becomes 15. So what is the answer? 12.
Yes.
Okay, that's right. Okay, let's see what's more in store. Now, we have some principles over here for addition principle of equality. So what we are, let's understand this and then we go ahead. So just tell me something, Ruthi, you must be having some friends. If I say that you and your friend had maybe 10 chocolates, both of you had, let's say, I'm indicating you as R only. There's, let's say, there's one friend which is A, and both of you had 10 chocolates. Okay,
From
now
here,
do
10
you
or 10 each.
10 each, 10 each. Both of you have 10 chocolates. Okay, so right now you are both having same number of chocolates. If I add two more chocolates to both of you, will it make a difference?
Yes, ma'am.
How?
Because we'll get more.
You'll get more, but can I still say that you have equal number of chocolates?
Yes, ma'am.
Yes, so that's what is, I think this principle is about. So the procedure for solving an equation in which a number, now here over here is subtracted from the unknown. So add the number which is subtracted from the unknown equation to both sides of an equation. So what they're trying to say is, let's say you both had, or else you had maybe 10 chocolates and someone took away from you maybe 2 chocolates. Okay. So in this particular case, if I add in, okay, if I can do, and that was something else as a number. If I have something else also as a number, then let's say this is x. Okay. So can I do like this, that 10 minus 2 plus 2 is also going to be equal to x plus 2? Is the first equation and the second equation same or not?
Yes, ma'am, same.
It is the same. So that's how the you can say the principle over here is saying the equation maintains its balance. We have not lost the balance of the equation. So that's what is the principle about. Let's see some questions over here. So they have taken some, we are solving for p. So here, if we have to solve, now there are two methods of solving, one which we have been always applying. So if ideally, I mean, the method, if we would have not learned this method, then what we would have done? We would have written p is equals to 42 plus 19, and then we would have solved this. Okay, we would have added this. But then there's an alternate method also, which is by addition principle of equality. What I can do? Instead, I can use this equation right like this: p minus 19 is equals to 42. Now, sorry. Mhm. Yeah, p minus 19 is equals to 42. So if what I can do, I can write p minus 19 as it is, and I can add 19 to the left hand side, and I can add 19 to the right hand side also. So do you agree that these both will cancel out or will become 0?
Yes, ma'am.
So this will be P, and again, it's just a matter of writing it, but then why are we dealing with it? I'll tell you. Let's finish this, then I'll tell you. So here, is the result coming same? Can you tell me what is the addition of 42 and 19?
Yes, ma'am.
Though
I'm
that
61.
is 61. Okay, that's thank you very much. Uh, Now the question is, why are we doing this? Now this could be a very simple problem wherein I could have just moved it, and here we are getting the solution, which is 42 plus 19. Here also we are getting 42 plus 19. But then at times there are situations when a question can be complex and we don't have any method. Then we can apply this method to make the question simpler for us. So you can say that we are right now just learning the method for the application in some complex situations. Is that clear?
Yes, ma'am.
I think this one also would be then clear to Ruthi, that y minus 43.5 is 6.79. So like you can see, it's a little bit complex. However, we are doing the same thing. We will be now, if we are adding 43.5 here also, and there should be this equal to sign, and we are adding over here also. We are adding 43.5 on both sides. So we are again getting the same results, which is 50.29. Can I go ahead with the next principle?
Yes, ma'am.
So tell me something, Rudy. Can I apply the same principle? I mean, if I would have had this as P plus of 19, and let's say it is equals to 42 only. Can I also subtract 19 on both sides?
Yes, ma'am.
Is it the same?
Yes, ma'am.
Okay. On that note, let's now see the second principle, which is subtraction principle of equality. So they're saying that procedure for solving an equation in which a number is added to the unknown. So subtract the number that is added to the unknown from both the sides. So here, if we had x plus 7 is equals to 12, so we could just subtract 7, and our answer is quick here. So we can see that this is getting cancelled. And on the right hand side, we have 12 minus 7, that is equals to 5. I hope it's clear.
Yes, ma'am.
Okay, great. Now, can similar things be also applied to multiplication and division? I mean, let's say if I had x plus 2 is equals to 5. So can I divide on both sides by 2, and does it change anything?
Yes, ma'am.
It changes or it doesn't change?
No, ma'am, it doesn't change if both are
It doesn't
divided.
change. Okay, did you check, or this is just a guess?
Well, ma'am, 5 can't be divided by 2.
5 can't be divided by 2, so you can't solve it further. You're saying this.
Yes, ma'am.
Okay. But do you know cross multiplication?
Yes, ma'am.
Okay. And also, have you seen, I mean, if I'm writing like this, can I not cancel also? Let's say this I have added. But then if I would have had any other such equation wherein, let's take an example, let's say we have 2a plus 7, and we have in common over here we have 4, and here we have 16. So how would you have simplified this, Ruby? Just skip this one for now and tell me what would you have done in this one. Is the question clear to you?
Yes, ma'am.
Yes. So if not, just let me know. I'll explain the question once again. Yes. How would you solve it further? There are 2, 3 methods and you can opt
4
any. Yes.
into 2a plus 7 minus 7 and then 16 minus 7.
Okay. Let me just clear the screen and maybe we can take it. It's 4 into 2a plus 7 is equals to 16. Okay. Just give me a minute. So it's 4 into 2a plus 7 is equals to 16. Okay. So here, what you would have done, you're saying, is you would have multiplied this inside. You would have written it as 8a plus 4 7 is 28 is equals to 16. Then you would have written 8a is equals to 16 minus 28. And what did you tell? What is 16 minus 28?
12.
Minus 12 or 12?
Minus 12.
Yes, so that be minus 12, and then you would have further written it as minus 12 upon 8. I think the result that you would have got is minus 4 by how much? 3 by 2.
Oh,
Is that right, Rudy?
yes, ma'am.
Okay. Now, can I tell you an alternate method?
Yes, ma'am.
Have you heard about cross multiplication?
Yes, ma'am.
Okay, so I want you to alternatively look at this. If I would have written the same equation, 2a plus 7 is equals to 16. Can I put the denominator as 1?
Yes, ma'am.
If I put the denominator as 1, can I multiply 4 on this side?
Yes, ma'am.
If I can I write this as 2a plus 7 is equals to 16 by 4? Correct?
Yes, ma'am.
How much is 16 by 4?
Uh, 4 upon 1.
4
So
upon
4.
1, which can be
So
written
4.
just as 4, right? So if I write it as 4, can I not further write it as 4 minus 7,
Yes, ma'am. But
which
ma'am,
can
we won't
also,
have to do 16 into 1 as well.
see, if you do it, I, I want to understand, Rudy, from you, what is the first purpose of understanding mathematics? I mean, whatever we learn from mathematics, what have you understood? Why is it important to know maths?
First to,
Maybe develop some logic, right? First thing, what I feel. Yes, do you agree or you disagree?
yes, ma'am.
Okay. Secondly, maybe as we keep on learning more and more maths, I mean, is it helping us simplify bigger things into, I mean, we are simplifying. If you see, this method actually took me a lot of steps to get to the answer, right?
Yes, ma'am.
Yes, wherein this method just took me 2 steps and I'm at the same answer or not.
Yes, ma'am.
So if I multiply 16 on the other side, which I'll just show it to you. If I do that, let me show it to you here. So let's say if I would have done 2a plus 7 is equals to 16. Now how will it get simplified? Now, let's say if I write it like this,
So
I
ma'am, it's
take
not
16.
necessary. We don't have to do it.
No, it'll see maths, whatever maths we learn, Rudy, we learn to simply. I mean, there's no point in making things more complex because we have to reach to one particular result. Abhi mein what if I just that's why I'm trying and showing it to you that why it is not good to do that. So if I write it like this, Is it solvable? Again, you will say, ma'am, multiply 4. Then you will multiply 16 on the other side. Is it, taking any step further?
No, ma'am.
No. So we will, why did I ask you this? Because I knew that because you have not learned this kind of approach, and this kind of approach will now be applied to these kind of concepts or else equations. That will always save your time for solving a question. Understood?
Yes, ma'am.
So, like I was saying, we could have, like, we learned about addition, we learned about subtraction, and now we will be coming to, let me just talk about the topic, that is division principle of equality, and also after this we have multiplication principle. So, the bigger picture over here is we learn about these things and then we apply to complex problems, which maybe are taking some time to getting solved, or else are complex to solve to be solved. So we can apply all these things to all those questions. Can I go ahead with division principle then?
Yes, ma'am.
Okay. So let's